Okay, so I'm going to make my own video regarding pressure and temperature affecting altitude because I think that this simulation kind of does a cool job of showing how the atmosphere works on a visual particulate level. Um, and there's a few different ways that this works, trying to compare it to the aviation world, but let me explain here. You'll kind of make sense. So this is a PhET simulation. It's basically about gas properties, but we can use it to kind of show the effects of how this changes, our altitude when we change temperature and pressure. So the first thing that I'm going to show you is this little man over here. This little man is pushing on the side of this box. Now inside this box, you'll see in just a minute here, is going to be our atmosphere that we're riding on top of. And what this little guy over here is doing is changing the size of this box. Now, in our scenario, there is a student who gave an analogy to an elevator sitting on top of a column of air, and we can directly apply that analogy to this simulation here. If you were to rotate the video on its side, pretending like this side of the box here is the top of that column of air, we can move that out to go up and in to go down. So what we're going to pretend like this is our true altitude um, above mean sea level. And over here is just a little pressure gauge. Now, this simulation measures in atmospheres. Obviously, we measure in millibars or in mercury. However, for the purpose of this demonstration, really the numbers don't necessarily matter as much as what the numbers do going up or down. So the first thing that I'm going to show you is what happens when we change the temperature while maintaining a constant pressure, which we don't account for. So we're going to add some molecules into the simulation here. And as you can see here, we're going to make the pressure go up a little bit because originally, you call it a vacuum. Now we have an atmosphere, which is sitting at that 1.3. That's fine. What we're going to do now that we've got a stable atmospheric pressure is we're going to set that as a constant parameter in the simulation. And what I'm going to show you is how pretending like this is an altimeter, which is holding a constant pressure, when we add or remove heat from the situation, look what happens to our true altitude without our altimeter changing. So if we remove heat, you're going to notice that, again, if you flip the video on its side, it helps. But we're going to actually shrink. We're going to go lower because that atmosphere is compressing itself because, again, thinking about it on a molecular level, these molecules are moving less. They can get more compressed. And again, if we add heat back to that situation, as we get warmer and warmer, our altitude is going to be higher and higher as we account for the same pressure. Okay, so now in a similar fashion, I'm going to show you guys what happens when we're flying from a high pressure area to a lower pressure area. Now, there's only a certain amount of parameters that I can keep constant in this scenario. So one of the things that's going to happen is you're going to see the temperature fall down, and it's just due to the way that this simulation works. But the properties still stay the same, and I'll kind of do my best to show you how that works. So again, our true altitude is sitting over here. This little man is moving back and forth. This pressure is showing our altimeter, and just as a reminder, with the lower pressure, that's reading a higher altitude, and higher pressure reading a lower altitude. So what I'm going to demonstrate here, so we've got a lid on this box, and what that lid's going to do is it's going to let out some of the atmosphere that we've got boxed up in here, which is going to lead to a lower pressure. And you saw this in the temperature one where this pressure was kind of fluctuating. Again, when we heated it up, you saw that pressure rise a little bit, and that was just due to the lag of the program as it's trying to account for additional, trying to account to keep that pressure constant. So what I'm going to do is try and hold this pressure at about 300 Kelvin, and again, this measures in Kelvin, but such is life. So let's go ahead and let this equalize again here. What we're going to do once this guy equalizes is we're going to let out some of the atmosphere in this box. That's going to simulate us flying from a high pressure area to a low pressure area. Now there's two things that you're going to notice when this happens. And the first thing is what's going to happen with your altimeter. What's going to happen with your altimeter is it's going to drop, which means that if you were to maintain level flight, you're going to see on your altimeter like you are climbing. Now what you're going to see over here, and this is kind of cool, is kind of your, I guess, reaction, which is how we come up with the from high to low, look out below, because in order to maintain level flight, you're actually going to start descending in order to keep that pressure at quote unquote level or the same pressure level flight. So let's see what happens here. We're going to open up this box, let molecules out. Now you're going to see this start to fall, and we're going to go and correct for it until we get to, and I might have done it a little too low, so I might
go all the way in here, but you're going to see we're going to descend to this point where, oh, our altimeter is still reading that same level flight where we were at before, but now we are way lower than we were originally. And the same happens when we go from a low pressure area to a high pressure area. We're going to add some molecules in here. We're going to see that pressure rising. We're going to feel like we're falling. And I'm going to add some heat back in here just to make sure we're back up to 300. But we're going to feel like we're going down, but really we're going to be going back up to keep that pressure at the same level flight that we were at before. And so that is how high pressure and low pressure affect your true altitude versus what you read, and the same with temperature. And really quickly, just to pinpoint kind of a key term here that I thought was kind of interesting. When we talk about density altitude, um, this is the reason that we call it density altitude is because of the way that how close that these particles are to each other. And just to really quickly demo that to you again, when we're talking about temperature, we can see that as we remove temperature, when we talk about density altitude, and how when it's really cold, the density altitude is sometimes even lower than the field elevation, because that's how density altitude is measured. What I want to show you is that, when we're getting really cold here, you can see we've got the same amount of molecules that are compressed into a much lower space, but we're still at the same pressure. And so that's what we mean by density altitude. When we're at really cold temperatures, we've got a lot more air molecules that are taking up the same space, again, with this lower true altitude at the same pressure. So our instruments change there, but that density altitude changes because of how close these molecules are to each other. And similarly, when we get really, 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 really hot and we're holding that same pressure that we were holding at, you know, well, that was darn near about close to absolute zero, but it's fine. You can see here that when we get really, really hot in temperature, we've got all of this extra space accounting for the same molecules just to keep that pressure. And there's a lot more space that's going between these molecules, which is why our density altitude gets a lot higher. Again, altitude relating to the fact that at higher altitudes, the air is less dense. Well, that accounts in the same way when we talk about temperature and pressure on the ground. As you can see, there's more space in between these molecules at a higher temperature than there was at a lower temperature. So I felt that was kind of worth mentioning.